Hi people, this is Mim. Let me give you the short version of this story right away.
Was too long, I didn't read.
Version. First, Derek Muller from Veritasium made a video about how DDWFTTW is possible. DDWFTTW is the abbreviation for going directly downwind faster than the wind, and essentially means moving faster than the wind pushing you. Then a UCLA professor disputed the claim and accepted a bet from Derek. Later, he conceded the wager and transferred $10,000 to him. But I still couldn't see how it was possible, so tried to debunk it, but more than anything else, ended up debunking myself.
Disclaimer!
Unlike either of these gentlemen, I'm not a physicist, but from my limited knowledge, I thought that Alex was right, so I expressed my opinion on Twitter, but got attacked by people and somehow was even compared to flat earthers for doing so. So I decided to make a video clarifying why I thought Alex was right, and that I never said anything about the shape of Earth. Come on, man! But in addition of not being a physicist, I'm also not a YouTuber, so please bear with me. To debunk DDWFTTW, considering my limited time, I followed one of the techniques I use in my day-to-day job as a solutions architect, something we call a rubber ducky method, which in short is to explain the problem to someone else, which forces you to break it down, take yourself out of the equation, and look at it in a third person's or duck's shoes, usually resulting in a better understanding of the problem by yourself, or even finding a simple solution that you couldn't see before. In the IT industry, because we usually have a ton of friends, we use a rubber ducky instead. This is where things got more interesting. When I started, I thought this was a simple physics problem. To me, maintaining speeds higher than the speed of what is pushing you sounded a lot like a perpetual motion machine. And although I am still not convinced that Derek's experiment proved what it was claiming, I'm not that certain anymore that it cannot do so.
Extraordinary claims require evidence.
You may disagree with me, but I can't say that Blackbird has provided enough evidence. But now, after digging deeper into the physics behind it, I can definitely see why this could be possible. I'm not yet sold on the idea completely. I still have my doubts, and I'll show you why soon, hoping you would either understand and sympathize or show me where I went wrong.
Let me show you.
First of all, please be my rubber ducky for a little bit and let me break the problem down for you in a way that worked for me. This can help especially if you are as doubtful as I was when I started looking into this. So here it goes. Let's modify our Blackbird here for a second and say that the propeller is powered by another source of energy and not wind. In which case, we all agree that it could go faster than wind. Now the problem is a bit simpler. We want to know if we could connect the wheels to the propeller with a gear ratio that produces more thrust, essentially by spinning faster. Let's break this problem into two simpler questions as well. Question number 1. Powered by the wheels, can we spin something faster than the wheels themselves, without having it connected to the propeller yet? Question number 2. If the propeller spins fast enough, could it produce additional thrust? We agree that the answer to both of these questions is yes. So what we are essentially saying is that the device could work. It's unintuitive when put back together, but all the bits and pieces seem to be working fine and in accordance to the laws of physics. At this point, I've had pretty much debunked my own debunking of the impossibility of such a machine. But it still did not make sense to me. It meant that we could travel at arbitrary speeds regardless of the speed of wind, limited only by the maximum inefficiency of our propeller. Imagine a sailboat that can sail with a speed of 100 knots on a slight wind. So I tried to reverse engineer my doubts and phrase them for my rubber ducky. I still had two big issues with this machine. The first one of which, according to the rubber ducky, could have been my misunderstanding of aerodynamics. And the second one is an assumption of limitations of energy potential between two mediums' energy differentials. Phew. Issue number 1. Is wind a continuous source of energy, just like an engine attached to the car? And don't be too quick to answer. Let me picture that for you. In his videos, Derek made another experiment pushing a differentially wheeled tool with a wooden stick and comparing it to the Blackbird, a discrepancy that seemed to be existing in the treadmill experiment as well. In both, we are replacing the wind, which is a liquid as far as the mechanical dynamics go, with a solid like a wooden stick or the ground as the source of energy. Is that fair? You can see in these graphics that I was thinking about wind as an incontinuous source of power, meaning when the vehicle goes faster than wind, it wouldn't receive any more power from it, but more drag. I could see, however, especially in the case of the treadmill experiment, that changing the frame of reference should be possible, and the fact that wind is more of a current than a point force. It's like a river where you are moving with everything around you. Nothing is pushing or pulling you from which you can escape by going faster or slower. So even though a solid object would not behave exactly like a liquid, I think in this case it's a fair replacement. Issue number 2. Can you take the energy from the wind and use it to push against itself to gain more momentum? Let me here too make the problem a bit simpler. All we are doing here is harvesting energy from a speed differential between two mediums, the air and the ground, and using it to produce more thrust against one of them, which will in turn increase the differential more, which again would cause more thrust, and it goes forever like that until we reach the maximum inefficiency limitation of our components. So there are two problems. When you go against the wind, which is what you are doing when you go faster than wind, the delta would essentially become a headwind. There will be a drag, which would slow you down. And since the initial power to go faster than the speed of the wind does not exist anymore at this point, because you have reached and passed the speed of wind already, then you should slow down again to capture more of that initial power. What I missed here, however, is that with the existence of another slower or still medium, the ground in this case, it seems like we can still use that to absorb the energy of the wind to gain more thrust, even though we are running ahead of the wind at this point. But again, it is important to note that we have indeed not only lost a component of our thrust vector, but also gained some additional drag. So the main question is if the thrust produced by the propeller is both cheap and big enough to compensate for the loss of our main source of energy, plus the drag and all the inefficiencies in the system. In other words, the propeller needs to move enough air to maintain our speed, or we would have to eventually speed down again, and 2, we would need to be able to keep feeding such propeller with the energy that was originally provided by the wind. What I am trying to say here is that if the system does not satisfy these two requirements in an ideal experiment, we would get into an oscillating thrust vector, which depending on the system configurations would cycle with a certain frequency through higher and lower speeds above and below the speed of wind until we would reach an equilibrium, like a pendulum.
Conclusion.
With all that being said, and no matter how wrong it sounds to me, these two systems, the Blackbird and the wheel differential tool, may be much more similar than what I assumed at first. Meaning if one is possible, the other one should be possible too. But where does all that additional energy come from? Veritasium mentioned that it is all from the wind, slowing down and giving us more of its energy. But I think gravity may be involved here too. In other words, we are sailing not only the wind, but also the gravity. My only wonder is then, how come such a system is not used in our long history of maritime transportation? This almost seems too good to be true, having great potential in reducing the cost and the pollution associated with sea transportation. It's just hard to believe that nobody has created the famous push-me-pull-you boat yet. At the end, I want to thank you both, Professor Kusenko and Veritasium, for such great science drama. It was an amazing brain teaser and I learned some new things. I personally appreciate it. And Derek, I also owe you an apology. And to all of you, thank you for watching. Please let me know in the comments what you think and have a lovely day. DDWFTTW.